to all. Today I will be discussing how to calculate resource based on deterministic method. Now I will do some calculation on the board which will explain you how to calculate resource in a very simple way. If you are in the field, you are in your class or anywhere, and if you have the parameters, use your calculator in the phone and you can instantly get a number for your original oil in place or original gas in place, recoverable resource and risk recoverable resource. Now in this board I have taken an example to showcase what I am talking about. The original oil in place depends on area, the net pay, hydrocarbon saturation and porosity. Formation volume factor. The area, convert it into square kilometer. The area is the prospect size which you have identified from the seismic method. The next three parameters, that is porosity, saturation and net pay thickness, is calculated from the well log. Formation volume factor and recovery factor are engineering aspect calculated from reservoir engineering and production data. So understanding of exploration, reservoir and production engineering can give you a holistic picture of resource estimation. In my classes, I have told you that deterministic resource need to get converted into stochastic manner, because you can understand there is no one number for area. You have a minimum area, you have a maximum area, you have a most likely area. You have drilled 5 wells in your block and 5 wells has given different pay thickness. That is the beauty of Mother Earth. So whether you will take 2 meter or 10 meter for your deterministic estimation is difficult answer. So normally we take the most likely value to do the deterministic resource estimation. But when you go into the stochastic sense, you take a range and you come out with the original oil in place, recovered resource and risk recovered resource as a range of values. Maybe the original oil in place answer may be 20 to 40 million barrels as an example. So the formula for calculating original oil in place is that area, which is in square kilometer, the net pay, which is in meter, the oil saturation, which is in percentage, porosity, which is in percentage, and formation volume factor, which is a ratio, should be plugged into the formula to calculate the original oil in place. In this example, area is 20 square kilometer, the gross pay is 20 meter. I have given you net to gross, which is 50%, that means the net pay is 10 meter, porosity is 12%, hydrocarbon saturation will be 1 minus of the water saturation, so it will be 70%, the formation volume factor is 1.01, recovery factor is 18% and probability of success is 20%. Just to remind you, the probability of success is calculated as probability of migration into probability of source into probability of reservoir into probability of trap into probability of cap. The original oil in place in this case is 20 into 10 to the power 6 meter square because it was in square kilometer. The pay, which is the net pay, is 10 meter, calculated from the gross pay with the help of net to gross. The porosity is 0.12 and the hydrocarbon saturation, which is 1 minus SW, is 0.7 divided by the formation volume factor, which is 1.01. You get the original oil in place in million cubic meter. 10 to the power 6 is million given by 2 capital M. 1 M means 10 to the power 3, 2 M means 10 to the power 6, and you get a value 16.6. You convert it into million barrel by multiplying with 6.29. It is not a strictose number, it depends on the pressure and temperature. However, the ballpark number is 6.29, and you get 104.4 million barrel as the original oil in place in this example. In the recovered resource, you multiply it with recovery factor, which is 0.8, that means 18%, it turns out to be 18.7 million barrels. And when you do it for the investors, for the banking purpose, for IPOs, you also have to give the rich recovered resource, which is given as 18.7 into the POS. In this example, it is 20%, so I multiply it with 0.2 and I get a value 3.77 million barrels. That is how you should calculate resource. This should be understood in detail and you cannot forget it throughout your lifetime. Thank you very much. In continuation to the resource estimation, we should also understand what is gross sand, what is net sand, what is gross pay, and what is net pay. All this will come from the well log. We will be looking into three types of well log in detail in future. One are the lithological logs, that is the SP and gamma ray. The next one is the indicator log, which is the resistivity. And we will be learning three types of porosity log, which is the neutron, the sonic, and the gamma ray. All log need to be studied together to understand these four parameters. I have drilled a hole during my drilling and I have found this lithology and the fluid content. From the top, which is 0 meter, I got the first oil at 100 meter and the last oil at 180 meter. In between there are sandwiching of shales. The last sand, which is between 190 to 200 meter, is water bearing. We should not puncture in water. When I see the indicative log, the resistivity, there is a very good resistivity peaking where the oil started and where the oil ended. So I know the gross pay. The gross pay is where we got the first oil and where we got the last oil. Whereas the gross sand, which comes from the lithological logs, comes from where we get the first sand and where we get the last sand. So the gross sand is 200 minus 100 meter, which is 100 meter. Whereas net sand are the three sand bands what we have, 2 oil bearing, 1 water bearing. So that is 20 plus 20 plus 10, which is 50 meter. But pay is talking about where the oil is or where the gas is. So the gross pay is 180 minus 100 meter, which is 80 meter, whereas the net sand are the 2 sand bands which are filled to the spill with oil, and that is 20 plus 20 meter, which is 40 meter. If you remember this figure, you will be able to calculate the gross sand, the net sand, the gross pay, and the net pay. Thank you very much.